Agnieszkę z domu już do Agnieszki zadzwonić, bo ona w tej chwili no, powinna być na nogach. Znaczy nie wiem, na jaką to godzinę jeszcze. Będę o 10 właśnie. Jeszcze 2 godziny będę, nie? Więc zadzwoń do Agi, a ja do ciebie jutro. Jutro w domu cały czas jesteś. No dobra. No. Ja będę próbował najwyżej. Znaczy jutro mam szkołę, kończę o 2, to gdzieś 3 będzie, to zadzwonię do ciebie, jak skończę szkołę. Już rana to już tam cię nie będę budzić. No. Zadzwonię. Tutaj nawet nie wiem, rozmawiać, bo słaby zasięg jest.
Who are you? Okay, good. 3 days ready. Couple of weeks off, and then straight back into it. Still that one way. Started at half 2, finished at half 5. Okay, when you get to because clearly don't want to between a sprint and a splitting. You're not 12 minutes. Yes. Does this make sense, anybody? We don't know what time is it. The last one, 3 hours. Sorry?
tad bit of the old They've got more.
Congratulations, sir, yeah. Oh, Angela. Okay.
Yeah, Angela. But I've never met your wife, so I can't say congratulations to her. That's why I joined Facebook, just because Alex, he liked your photo on Facebook. He came up with my feed that Alexander Zoko likes this photo and it was your photo. So I was like, oh, nice.
Good. It's your turn to do the introduction.
That's good.
But it's still not.
Yeah.
really hateful people. No different. If I bought you fancy in the coat, it would not. Always something to complain.
get your attention, please? If you could all like gather around in a circle around the room.
What the hell is that bugging
Hi everyone, and welcome to February Tech Meetup. This event is kind of brought to you with the help of our sponsors, which are Skyscanner, Cultivating Informatics Ventures. I guess just by show of hands, please raise your hand if this is your first Tech Meetup, just to kind of get an idea. Cool. Well, I hope you enjoy it. So a few announcements, like there shouldn't be any fire alarms going off, but if there are, like the fire exit is just there on the left, straight out. Yeah, just in an orderly fashion go there, but hopefully, we've never had one, so hopefully we won't have one. Also, please don't sit or lean on the tables at the back, because they kind of, you'll fall. We've had that happen, so we're talking from experience here. So like for the benefit of people who are here for the first time, usually what we do is we go around the room, we say our name and kind of what we're here for, and I guess I'll start. Hi everyone, my name is Marius. I'm an iOS developer and I help organize TechMeetUp.
I'm Alistair, I do the door and AV at Skyscanner. I'm particularly interested in people who've done any .NET on Linux at the moment, because I'm interested in like moving a bigger application over to run on that, and also people who've done sort of advanced toolings for like Lambda functions, so like to actually do like testing and big repositories and all sorts of stuff.
Hi, I'm Mia. I'm one of the speakers today. I'm an iOS and Android developer. I occasionally touch some server-side Java, but I try not to.
Hello, I'm James Baster. I work on Open Tech Calendar, which lists all the tech events around the area. If anyone's played with Let's Encrypt, the new free SSL certificate provider, it'd be good to chat.
Hi, I'm Niall. I'm an Android developer for Bitwink and also create my own application called MyBus Edinburgh that some of you might have used. At Bitwink, we're currently looking for Android and iOS developers with an emphasis on lead Android developers, so if anyone's interested, then let me know.
Hi, I'm Adam. I'm a computer science student at Edinburgh, and that's pretty much it.
Hi, I'm Ellie. I'm also a computer science student at the University of Edinburgh, and I came here because I've heard it at school.
Hi there, I'm Stilan. I'm a student and I came to check out presentations in Apps and Pizza.
Hi, I'm Isam. I'm new to the whole thing basically. Trying to meet up someone who's interested in PHP.
I'm Ben. I'm a motor control engineer in the automotive industry. I'm here to chat to people and see tools.
Hi, I'm Mike. I'm a freelance coaching consultant, C++ guy mainly, and I used to work with Mia, so I'm here to hear her talk tonight.
Hi, I'm Aisha. I'm creating my own business, a platform for social media, like Laurel, who I've just basically stolen what she's going to say probably.
Yeah, we're trying to create a platform where you buy something and you give something to charity, give a roundup at the point of sale, and we're looking for people techie people to come and help us build it.
My name is Ivan, and I'm a year 2 student at the University of Edinburgh, and it's my first time here, and just interested, so just see what's cool. My name is Alberto. I'm in second year 2, but I'm studying computer science, and yeah, I'm here for the same reason.
Hi, Hamish, third year uni student looking for internships, practically all standard languages.
Hi, I'm Harry. I'm a fourth year student at Napier doing software engineering. Here because the talk sounded good tonight, and also I'm looking for internships over summer.
I'm Kyle. I'm a software engineering student at Napier and also president of the Napier Developers Society. If you're interested in reaching out to either do talks for our society, like talking about technology do, the company you work for, or if you're trying to get people for internships or placement years or graduates, then come talk to me because we have a bunch of people.
I'm Akin, student of Edinburgh University. I came with MPS just to see what's happening.
Hi, my name is Valdez. I am a computer science student at Edinburgh Uni and care for network.
Hi, my name is Ibrahim and I'm a student of computer security in ATLU. I came here with my friends just to see what's going on.
I am John, also a student, furniture student who went for Alpha. I'm at the NDS guys as well. I came along to see what the TechMeetUp was going to be like. I'm Ginger.
Kind of juggling bringing up kids and doing a bit of work down there. So kind of looking to find out what should be getting good at for when the kids go back to school after the summer. So they can get really good at it. So
I am Thomas. I'm a lecturer at Edinburgh University. I've got my own company, Phoenix Services, in web development. I am also coordinating Stockholm PhD, so if you want to discuss PhD, it's very good to me.
Hi, I'm Andy. I work for Student Medical, for the Image Analysis Research team. We do processing and machine learning, mainly C++.
James, also Student Medical. Work in the visualization team, writing renders that go fast in C++ computers.
I'm Gordon. I'm the technical director of a small company that we founded a couple of years ago. We do 3D stuff for the rail industry, so all of the new trains that seem to enter the UK, we're doing virtual rules of us at the moment for training and for maintenance and that kind of stuff. And I'm here to see the talks.
I'm John. I'm a front-end JavaScript developer, mainly doing React stuff.
Hello, I'm Dan. I'm the TechMeetUp service.
I'm a tech lead of a pet team at
Hi, I'm Callum. I work for Amazon. If anybody would like to code review my process code, because I don't really know what I'm doing.
I'm Archie. I work at Amazon and run a couple of teams. I'm trying to hire 17 people. Across all kinds of web, machine learning, front-end, back-end services, data. I'm talking about.
I'm Barney. I work for Lucid. I'm just a
I'm Joe. I'm a full stack developer at Outreach. I also run the C++ meetup in Edinburgh. So I already know some of you because you've done. If anybody else is interested, please go down.
Hi, I'm Deepa. I'm president of Brand Johnson. Hi, I'm Roxana, a C# developer, and I'm looking for new opportunities.
Hi, I'm Kolosh. I'm a BI/BA consultant at Stereo. We have a grad scheme for all the students here, and I'm here for the talks.
Hi, I'm Toby. I'm the CTO of Urban Tide. We're a small startup based in Courtbase. We're building a new data platform for smart cities. We're looking for developers. So any full stack JavaScript developers, please talk to me. And
I'm Karen. I'm a student. I'm starting a love-hate relationship with hardware and C. In that I really like seeing my work in the physical world, but I hate the ugliness of the code.
Hi, I'm Duncan. I work for small IT companies, IT projects, and anything computer related. I'm also working on a network here for Steven.
I'm Dale. I'm an iOS developer for Microsoft. This is the first time I've been here in well over a year, so I'm here to see what's kind of been going on for the last year.
I'm Nerea. I'm user interface designer and
I'm Zuma. I'm a telematics engineer. I work in the Gold work through the global operations of Microsoft and just reception of customers.
Robert, do ruggedized hardware, software, interfacing that kind of thing. Looking for someone to help us out with the project. Let me know.
I'm also software engineering.
I'm Rob, Edinburgh Backlab, Edinburgh's hyperspace. Feel free to come to our open nights and try to be Tuesday.
I'm Tim. I study robotics, but I actually PHP developer and that's mostly learning React. It's fun.
Hey guys, my name is Mahmoud. You can call me M if you can't get my name. I'm a student at Edinburgh here. This is my first semester at Edinburgh, so you know, just trying to socialize, get to know and stuff. So.
I'm Rick. I'm a fourth year computer student here. I'm also a test engineer at practice to do software outsourcing.
My name is Monica. I'm a master's student in computing at Edinburgh here, and I'm desperately searching for inspiration for my master's dissertation.
Hi, I'm Darren. I'm a fourth year student at Napier. And yeah, I'm just here for the talks.
I'm Danny. I'm a software engineer, and last meeting was my first meeting, and it was quite fun, so I'm back.
I'm Michael, second year student at Napier doing computing. I'm one of the developers society.
Hello, I'm Michael as well. I'm a software engineer at GB Group, and you've come to TechMeetup, so I wouldn't know what to do every second Wednesday.
I'm Chris, C# .NET full stack developer, and I'm here for the talks here and catch up with friends.
I'm Tom. I'm part of a startup based in Berlin, but I'm looking to set up a new development team over here. We've got projects in infographics, data visualization, music streaming, ebooks, timelines, and we've also got a card game as well, all with web technologies. So if any of that kind of interests you, please speak to me.
Hi, I'm Alessandro. I do research in Heriot University on deep learning, and just here to see what's going on.
Hi, my name is Marius. First of all, I'm working for a company, quite exciting company, XDesign, who are looking primarily for mobile developers and some executives, I guess. But so if you are like looking for that type of work, talk to me. Secondly, I'm started working on this, like my personal project regarding video live streaming online. So if someone's interested in that kind of stuff, collaborating with me, just come talk to me basically.
Hi, I'm Ewan. I'm representing iProspect, which is a marketing agency. We're looking to hire web developers, people new to the industry, because we'll train you.
I'm Naya. I work with Ewan, and he said there'd be pizza, so no disappointed.
Hi, I'm Scott. I'm a test engineer at Seabright, and I'm just here for the talks.
Hi, I'm Aaron. I'm also a test engineer at Seabright, and just here to see the talks too.
I'm Yvonne. I'm a master engineering student at Edinburgh, and I'm just to see what it's all about.
Hi, I'm Katie. I work with these two at Seabright. We are recruiting at the moment. It is in Southampton, so we do command and control software for unmanned underwater vehicles. So if you can code the C++ with Java, come and get my card, and I'll see if we can sort something out. Thank you.
Right. At this point, like, does anyone have any announcements they want to make, meetups they want to promote, or? Well, in that case, we're gonna start the first talk in about 15 minutes. So the toilets are just outside reception, just because we're gonna take a 15-minute break for anyone who needs them. They're just out there. So we'll see you at 5 to 8.
Nice.
go through some
What style? I'm just
what would be the specified? Quite a small tool.
Yeah.
What kind of lights do you use?
Let's say like YouTube, but they are concentrated like mostly on games. So I have this idea for like more like children entertainment. So what we do, finishing the design of the website, so to speak. Not actually finishing in the middle, but it's in the better life project. So technologies involved would be, well, probably for broadcast, we recently Java, picking up the camera input and broadcasting settings. And there would be, the main website will probably be 7. Of course, JavaScript, HTML, something, but mostly PHP. And actually, I'm still trying to work out in the beginning, I'm probably going to use AWS, but it's really only for a year. So I have also another thing regarding this business model. So YouTube and that kind of stuff based on ads. And I want to do kind of put the pricing in the actual people's hands, and they will be able to set the price basically with some restrictions and with some restrictions. So
they will set up the price.
Yeah, of course. At the beginning, they will put up stuff, and so on the website there will be no authority for the video. If you wanted to post pre-recorded video, that would come from YouTube or whatever. And the site would do only like basically live streaming. So, you know, it would be, I imagine like this, they would put YouTube videos for like people to see what kind of stuff they do, and maybe do like paid live streams for the targeted audience or something like that. Different opinions. I'm still trying to work out what groups would fit into that, like say stand-up. Or music, of course music, but stand-up maybe not. Like I'm still like trying to finalize this
we are very, very laser focused.
Yeah? I'm standing all the time in front of that, and it's like, is it recording me?
I would personally suggest I can't be using my biggest you can see only like a lot of places this morning, show like
yeah, like in terms of what you're doing.
Let's say it's like for events basically. It's not like, okay, it's for gaming, but it's like two people sitting in the top of it's like with the TechMeetUp this provides because YouTube doesn't have, as I can see, clients so that's
I'll definitely take a look around because I'm only starting to come across a bit more like the professional games areas around here. I'm only being here for a year and a half. That's a very low-tech version of it.
So, you're incredibly qualified for the job already, I can tell you that. Like, you're seriously qualified. So, straight away, I'm going to give you a card because you should already know that. It's obviously right to let's do it there. We'll read over it and get back to you. You're definitely qualified for it, but I've only feel what it is anyway. So, what we do, we're a very new team as part of the agency. So, iProspect itself is global. We employ thousands of people. It's a huge thing. It's part of an even bigger thing with NCUA's network, which is incomprehensibly large. It's massive. And that's formed of loads of different marketing and those kind of agencies. We're big enough to have proprietary software automation, like this, which is how ads are bought. And that requires like projects and automation of big size projects. So we're big enough to have those kind of projects in-house, which is great because it's all integrated. What we provide in Microsoft is actually a really new, it's new and very small and fast growing called Dynamic Creative. In advertising, giving you work on like the four things you want to get is the right person, at the right time, in the right place, with the right message. Web advertising right now is conventional, preaching and interacting with all those kind of cool but dark, there's no clever thinking. It gets the right person, the targeting your audience better and easier to do so, profile interests and that kind of stuff really well. Right place is easy enough, you just sell the right websites, you get golfing ads on golfing websites, you get driving ads on driving websites, that's easy. Right time, you get down to the second, again, really easy if you want to sell sporting tickets out of sporting events, again, really easy. What isn't so easy is right message, because you have one creative, so that's one instance of a visual design with a certain copy and a certain image in one creative. So you have one creative for possibly hundreds of thousands, if not millions of impressions, and that's just not a very good hit rate. If advertising is kind of a scattershot game, you go big numbers and hope it affects some people. We're doing everything we can to optimize that, and so having one message for so many people, it just can't work. It can't work. Psychologists said it can't work. So what we do is we get the right message to the right person, and we do that by putting out of our office not completed creatives, but a template that is basically infinitely variable depending on how we configure it, which can be dynamically populated using data from a database, targeting specific data from target analysis. So we can change basically everything, it's just injecting code. So you can do anything you want. But the most common things are changing the content of text, changing the copy, and changing the images. That's what most people get out of it. So rather than, for instance, the first thing they did was I did. So the ad, after we got our hands on it and finished, wasn't shop at IJ from Sports, it was buy these trousers that match the strengths of this report to levels ago. And that takes pride in place on the creative rather than just generic brand. There's other people that do that. A company called Sponge is one of our biggest competitors, and they're good, they are good. But the difference is they're not bespoke. So they have templates that a client comes in and they pick from a list of templates and tailor it a bit. And it looks good and it's solid, but it's not really brand aware. And in advertising, that's literally everything. It's our entire job. So what we do is every single client that comes in, it's a completely fresh slate. We work from the ground up. We generate our own assets or work with a creative agency that's done design work for them. 100% bespoke, 100% brand aware, and they get completely artistic package. So the skills we use in that are actually very narrow. It's a very narrow slice of everything. Because we work with Google, one of Google's biggest partners in Britain, so a lot of access to the piece of technology they put out, they're really good working relationship with their tech team. But Google has certain requirements when they deliver ads, security concerns. Because obviously if you're delivering to possibly millions of people, there is a big opportunity for exploits. Like even just trashing a browser, which is obviously really easy to do with JavaScript, that's dangerous. So to try and minimise that risk, we only use JavaScript, CSS, and HTML, and even then there are many APIs and stuff we can't use in JavaScript unless it's been completely checked out by Google, and it can be basically run locally on local files. So there's no access to servers or anything like that. It has to be all in English. It's laser focused skills, but as long as you're HTML and CSS savvy and you've got any amount of programming knowledge, you'll know how JavaScript works. It's really intuitive. You're totally what we're looking for. And it's good, we're going. We're in an interesting place right now because I prospect, and especially Karen, who we share offices with, so it's kind of like one corporate policy among 3 companies. It's a bit shifty there. Carrot especially are a very traditional company, and they're not particularly hot on that media. But, with the introduction of the creative team, myself, Naya, and my bosses, our co-worker, we're changing that atmosphere a bit. So for instance, Carolina, who's a mother of 2 children, she works at home 1 day a week. And that's an arrangement that I'm fairly sure only she observes in the entire building. So I can't promise anything, but that but one of our bosses also says that conversation's been had, it's had results. I can't say anything, I'm a lowly serf, but it has happened, so that's totally something to talk about.
Get to start and if like you can discuss it and then you can start a chat and like work with longer like afterwards. So it's so flexible enough that
Especially around like childcare. It's a bit of that age where everyone in the office is having kids, so I think everyone's kind of that way minded. The only what you compete with that is the advertising world works on a really strict timeline. Everyone knocks off at 5:30, everyone starts at 5, and you get really pushy people wanting to finish that at that time. So, we quite often get at 5 o'clock hanging out and then coming in and they want to go to the play, and that's because they understand people have lives. So that's what we're competing against. But like I said, they're happy the accommodations have been made totally. And I would absolutely recommend us to he's a really cool guy to work with. A pleasure. What's your name? Mora. Nice to meet you. Yeah, and I'm you. You got my card, but not my card. Fantastic. Thanks very much. She's no interest. I think when she realised that we deal in contracts that change the value, not really. So no, we're like, if we want to do a contract, like a 3 aspect, to do a 1 minute it's a naughty word. I think I fucked the introduction of it. I was way too short. I capitalized it. I'm trying to remember anyone that we saw that was interested. Yeah, or if anyone mentioned being like down to that kind of thing. I'm actually looking for work. If you know what I mean.
Did you say you were going to hire interns for training?
Not even hiring interns. Fully fledged living people.
Oh, just anyone?
People who can recommend them. It's quite experience to go through and five.
Prospect, we're in Project Edinburgh. The project itself is like
train them and then
yeah, it's sort of what we're so nice at Project Edinburgh. We're selling pretty good at selling products with pretty dedicated course. So because of that, we're fully versed in this. So people who are fresh, motivated, interested, motivated.
Are you interested in students like years placements or is it full time? I mean,
yeah, obviously the work is full time. It's a full time. But there's no way.
Right, everyone, can I get your attention, please? If you can have a seat.
How about
we're going to start the first talk of the evening.
This is not me. This is as it feels. It's also really good.
Thanks very much.
You should join maybe a
So, he is going to talk to us about debugging web services with Charles. So, yeah, you're in.
Perfect. Thank you all for coming. So I'll start with an introduction. I'm Mia Alexiou. I've spoken here before, and I'm an iOS and Android developer. If you want to get in touch, please do. I'm trying to be nice to people, so feel free to email me if you have any questions at all. Feel free to tweet me. I'm always happy to answer any questions. Corrections as well. Feel free to say those. Okay, an advance apology. Today I am speaking about Charles. I'm going to have about 5 tools on my screen. And when I ran through this yesterday, Charles crashed twice. Android Studio Instant Run had decided to fail after an update. And things were not looking great. So I'm expecting something to go terribly wrong during this talk. So it's a live demo, and we'll see how we go. But Charles is a great tool, but it's not the most stable tool I've ever used. I will say that much. Okay, so I'll give you an overview. What is Charles? It's a web proxy which allows you to watch and manipulate web traffic. So it's pretty simple in that respect. It's cross-platform, which is nice. There's some other tools, but not all of them are cross-platform, so it's a good reason for me to use Charles. And the way I use it, because I'm an app developer, is I will generally run Charles, the app on my machine, and I'll point either a device, like a mobile phone, Android or iOS, or I'll point my emulator to Charles and watch all the traffic. And that's quite useful for me as a developer because one thing I often do is connect up to web services. So what can you do with it? You can view traffic. You can stick a breakpoint on a request and watch it go through just to make sure it looks okay. You can edit requests, you can edit responses, you can do automatic rewrite rules, you can repeat requests, throttle, and just start cancelling and aborting requests. So it's a pretty useful tool to have if you want to see how your app will react to different types of traffic and you want to manipulate it, and your web service on the other side doesn't let you do that too easily. So sometimes we have split up teams, and what the other team that's doing the web services for you is producing doesn't necessarily match up with what you need for something you're testing. So that could be useful to do that. Now obviously this is just debugging. We write unit tests for everything, but when we get to the kind of integration test level, we're limited by what the server will give us, so this is a good way to just test or check really edge conditions. Okay, so why do I need this? Let me give you a demo. Imagine I'm a mobile developer and I'm connecting to a new API request. So writing a new app, and it's beautiful. I will show you what it looks like in a minute. It is the best app you will ever see. Spend a few minutes on it, and I need to connect to a web service, and something's going wrong, and I don't know what's going wrong, so I need to find out. So I will switch over to the gorgeous app. This is what it looks like, just like one of the Android demos. That's obviously a coincidence. And this is Charles over here. Now, you can either watch requests coming through in this structure panel over there, or you can look at the sequence panel. I just sit in this panel here. And what will happen is if I press the plus button, I'm going to see the weather for Edinburgh. Very exciting. Or I'm not going to see the weather for Edinburgh because I'm trying to connect to a web service and I've done something wrong. Okay, so on the left-hand side, we're looking at this Open Weather API, and something's wrong. 401 unauthorized. So I can quickly see what's happened there. I'm looking at the request, there's some parameters, and the response has given me some JSON, very helpful, and it's, again, repeating the 401, I'm not sure why, but there's also a message which is telling me that it's an invalid API key. I'm like, oh, damn, that's right. This is one of those web services where you have to register for an API key. So let's have a look. So this is the Open Weather Map service I'm trying to connect to. And I haven't got an API key, but what I'm going to do is I'm going to steal the one, thank you, that's and see if I can get away with that. So, this was my request earlier. I'm going to stick a breakpoint on that. I'm going to repeat the request. If I can remember how to repeat it. My resolutions are different. There it is. And it should come through for me to edit it. I'm going to stick that API in there and think, does that work? Ta-da! It seems to work, so I'm getting the right response. Perfect. Now I'm going to do it in here. So I know that'll work, so I can code it in, but I want to check with the app whether that'll work. So I've still got that breakpoint there. I'm going to edit the request again, throw that API key in, execute. And look at that. We have the weather. So that's pretty useful if you're connecting to an API where there might be a lot of things that are wrong, the docs might not be right, so you can quickly just keep hacking away at the request till it works, and then go back to your implementation. And you've got a record of everything that you've done. So if I look at this overview, actually it won't show me in this. Sometimes you get some notes about what you've manipulated, but not in this case. Okay, so now I go back to my code. I'm going to add that API key. Run that properly. Instant run's not working, so it's all a bit slow at the moment. I'm going to switch off that breakpoint because I don't want that anymore. And just make sure that that's working. Okay, so that's proper connection. I'm not manipulating it, and it's all working through the app. Perfect. So that's our new API connection, and we've managed to edit both repeat a request, edit a request. We can also edit the responses coming back from the server. So one thing that could have happened is I could be looking at this and thinking, let's say we do have a proper server team. I could be thinking, that description down there, that's not correct. So that should be like a really long description, and that's not quite right. And I'm worried that my UI won't stand up to the real data. It may not expand properly. So I'll stick another breakpoint on all that. Okay. So I'm going to pop another breakpoint, and what I'm going to do this time is just edit the incoming request. Okay, this is one of these great examples where Charles is not quite working. So what should happen there is when I make a request, I get to execute it, and that's the request itself, opportunity to edit. At this point here, I should get an opportunity to edit the incoming response. Charles is now failing me, and this is a typical thing that will happen to you when you're using Charles. And the trick is to quit Charles. And open Charles. So I'm glad that I got to demonstrate some of Charles. It's not always this buggy, they're just being a little bit weird in one of their recent releases. So hopefully if I update, that will get sorted out. Execute, show me the response. It's not going to show me. Okay. So that should come back. It's not happening. But what I would do there is exactly like I edited that request going out, I would edit the response and I would be able to see it in here and see the data that I'd edited come up on the screen. So it's not terribly different from editing the outgoing response. The outgoing request, getting the incoming response edited as well. So one thing I will say is child is a little bit buggy, but it's never been as buggy as it has been in the last 24 hours for me. I don't know why it's so bad. I use it all the time, and I do recommend it as a tool, otherwise I wouldn't be up here giving you this overview of its great features. Okay, so another thing you can do is you can create rewrite rules. And rewrite rules allow you to edit the incoming content automatically. So it's a bit slow if you're sitting there and sticking a breakpoint in, grabbing the request or the response and editing it. So you can create a rule that says, okay, whenever I get this type of a request, I'd like to rewrite it and have a different response. So I'll give you a interesting example of using rewrite rules. I had my backup plan today in case anything went terribly wrong and there was no Wi-Fi. And I've set up a bunch of rewrite rules. And what I've done is, when I make these requests, even though I've got no Wi-Fi, it'll automatically provide the response that I'm expecting. So we hope. So let's see if they're working. Yay! Okay. They are going to localhost. And my rewrite rule is working. And my response, okay, not quite working. Okay, so that's my rewrite rule. Every time I go to openweathermap.org, it should be going to localhost. That's happening, sadly. These other rewrite rules that actually take that data, which do work normally, I don't know if it's this network, are not currently working. So this is a total disaster. Let's try that. Nope, definitely not. So I'm going to try my trusty rule of killing Challenger, starting it again and hoping for the best. There we go. So now the rewrite rules are worked. So excuse the failed demo the first time around. So I've got no internet connection right now, and I've copied some previous requests, added some rewrite rules, and I can keep going. So it's quite a useful tool as a developer. Let's say there's a new API request that is being developed, and your server team's like, hey, we haven't finished that yet. And you're like, oh, sprint ends tomorrow. They're like, you'll have it tomorrow. At least you can go to the web page where you've got all your specs set out and mock up the UI and have that ready. And then you can hopefully deliver, and with the press of a button, it'll all magically work as long as you don't find out that they haven't conformed to the spec. But even if they haven't conformed to the spec, you can create a rewrite rule and say, ta-da! If they had conformed to it, that would have worked, and this is what it would look like while you wait for that to be delivered. So I don't know how many of you are front-end developers, but often in a sprint, you're waiting for designs, you're waiting for the server, you're waiting for everything. And everyone finishes their work and they kick back and relax. You're like, it's the last day and I just got everything. Because at least with this tool, you can keep going. And it just means that I can keep working when everything else is going terribly, terribly slowly. So we've demonstrated kind of mocking up connections as well. And some other things you can do, like I mentioned before, is you can breakpoint, response edit, you can throttle, you can abort. So often if I'm just checking the app to make sure it's stable, I'll suddenly throttle. Something I've seen other people do is they'll throttle their whole machine. Don't do that. Charles has an option to throttle a particular URL. You don't want to sit there and slow down your whole machine. I've seen a lot of people do that. And another thing I do is I'll just start randomly killing off requests. So they'll come through Charles and I'll just go Obviously, this isn't real testing. You want to write proper unit tests, you want to write proper integration tests, but nothing beats giving your app a good shake up before you send it out live. Okay, so that's the introduction to Charles. It is buggy. So these are my finishing thoughts. It lets me keep going even when everything else is being slowed down, so it means I can be a productive developer. The bad bits, the user interface needs some work. I should have written up there, it's buggy. It's not open source, it's not free. I still think it's worth it, so that should tell you something, even though it's probably not the best app imaginable. I will still happily pay for it and happily tell everyone else to pay for it because I use it pretty much every day. There are some alternatives. If you're a Windows person, you might like Fiddler. There's something called Burp Suite, which I've never used, I only heard about it yesterday. And that one is meant to be a Java cross-platform app, so that might be worth trying. But I haven't personally used it. I have used Fiddler before, but I'm not a Windows anymore, so I don't go near it anymore. And there's also Wireshark, but that's much more low-level networking. And if you're a web developer, you probably have a million cool, funky tools that you already use. So thank you. That was just a quick intro to Charles, a cool tool that you might like to use if you're a front-end developer. Also, there's a shameless request for support coming out. I'm running a marathon, and they are really hard. And fundraising is even harder. And the charity I'm raising it for is Deafblind UK. And being deafblind is even harder than fundraising and even harder than running a marathon. So if you donate, you get double good karma, so feel free. No pressure, but I just thought I'd mention that. And do please stay in touch. There's my Twitter handle. Does anyone have any questions?
Do you know if Charles connects to the network interface, or if it's like attaching to the process, or is it like how's it figuring out the traffic?
So I'm not sure exactly, but it works as a proxy. So I don't know exactly where it slots in, but you do direct your traffic to it as a proxy, just like you would any other proxy. I hope that helps. If anyone can answer that, feel free.
Just wondering, how does it deal with encrypting using SSL?
You can set Charles up as a certificate authority, which I always do because everything I do is over SSL. So that was just a nodding example of a HTTP. But everything I do is over SSL. So if you look at Charles, it makes some things easy for you. In this help section, there's SSL proxy, and it has a bunch of options. So if you press that button, it will automatically set itself up on your iOS emulators. On my Android device, I set it in the Wi-Fi settings to use Charles as the proxy. So it depends on what you're on, which web browser, but you can set it up to snoop SSL traffic, so it works as a manual. I don't know how it works with certificate pinning. I've never tried it. I've been told it works, but I've never tried it myself.
What sort of throughput would it support? Is there things like you can run things through streaming?
I doubt it. It's pretty slow. I've never tried streaming. It's more for just watching JSON and pretty light traffic. I don't imagine it's too great because it gets pretty bogged down by normal networking. But I could be wrong.
Do you know why it's called Charles?
No idea.
Do you know why its app icon is a mug? Or Java?
Not sure, but I'm curious now. I'll have to find out.
Besides bugs, is there anything missing that you like in Charles 2.0?
Not really. I think the features are great. I would just love them to fix the bugginess. I think so. I think very recently they've added that feature, but I haven't used it. I believe so. Maybe you need to check that out.
One last question. No? Thanks, Mia. So we're gonna take a 10-minute break, and then we're gonna have a second talk. Use that opportunity to use the toilets or whatever, talk to people. So yeah, see you back in 10.
Yeah.
But it's usually better if you just say, focus on this, and you do yourself. Well, people all sit down and they go, I'm trustworthy. Change the starting point, yeah, Windows, I've got so I one car said when it was DNS
Oh, right. Yeah. So I'm already like. But I saw you said you are. Yeah, but. Yeah, sure. I can't remember who else said people
Right, everyone? We're going to start the second talk of the evening. If you can have a seat, please. Right, so for our second speaker, we have Robert talking about symbolic logic. Let's see what that is. Go for it.
Thank you. I've got my pointing device. Right, so this talk is really a plea for help from people from the real world. So this is academia leaking. And what I want to do is try and convince you that no matter what you may have heard, formal methods is actually practical and useful. Symbolic logic is practical and useful and could be used in real world programming. But we don't know what you want, what you need. And I'm asking you for help to tell us, me in particular, but our group and the university, what you need to help you write better software. So, who am I? I'm a lecturer at the University of Strathclyde in the Computer Information Science Department, and And the group I work in is called mathematically structured programming. So we think that programming would be better if there was just a little bit more thought put into how we structure things. Surprisingly, this is a controversial opinion. I mean, we just want to make it slightly better. And we use maths to do this, maths and logic. And why am I here? So I want to do applied logic. I want to sort of take logic, and there's people who do applied maths, and they do things like they optimize the number of trucks that flow through the DHL network and things. I want to do applied logic. I want to apply logic, or some people call it formal methods because they wear ties, or they do call it verification, and to address issues of building software. Now, I believe that logic can have a transformative effect on software, but I need your help to actually prove that to people. So the problem is, I think people are interested in this. So I said using mathematical structure is a controversial opinion, but how do you actually use applied logic to do this? And the problem is there's a bewildering range of concepts and tools. There's propositional logic, personal logic, functional logic, linear logic, type theory, model structure theory, improving stat solves, listen to solves, scattering theory, pure functional programming, Hoare logic, linear types, polymorphic types, higher candidate types, dependent types, operational systems. I've never gone on to the tools. Coq, Isabel, Z3, Daphne, CDC4, Agda, Idris, Lean, TLA+, Prolog, Datalog, Haskell, something like that. I mean, Idris is developed new here, it's developed in Los Angeles. And there's just so much choice of things to do. What do we do? I'm sorry, I should have also added new power, because I think, sorry. I just don't know who's going to there's so many different tools to choose from, and it's kind of bewildering. And all of these things take years to learn. I mean, and I think it makes it look more complicated than it really is. So let's go back to the start. What is kind of doing formal methods for software? So the traditional view is the following. We write down a specification, and don't worry, this is the only Greek letter I'm going to use. Phi. And then we write an implementation, P, and then we prove the implementation satisfies the specification. So this symbol here means models. So P models the specification. So now, there's obvious flaws with this. I don't know how anybody else writes software, but I don't know what it does until I'm halfway through doing this bit. I'm not sure what it's meant to do until I got to the end when I finished. So I can't get past step 1 without doing step 2, and already I've done it wrong. Already I'm informal. And this bit is sometimes often very hard. Sometimes this bit went wrong, and I've actually specified impossible things. Sometimes I've written a specification which is just trivial. Any piece of software would have satisfied it. And this is very hard. And let's call this the big upfront specification technique. But if you went to Edinburgh University in the last 10 years or so, you may have been taught this. So let's do rebranding. So for example, there's this nice, I won't say the whole of Amazon, but Amazon Web Services, they use a system called TLA+, to verify some aspects of their of AWS. And they found, apparently, according to an article they wrote, that instead of calling it formal methods, they got more uptake from developers by calling it exhaustive testing. But I want to sort of push a different idea, and the idea is, well, we collect data, so we collect, so a lot of sort of the value, let's say, in a lot of tech companies is the data they collect. They have user information, or they have logs, or they know what purchases people make, and they can use this to sort of query it to learn trends and problems and opportunities and things like that. And they write queries in SQL, and they write custom analyses, they might write things in R, or they might use Julia, or something like that, or they might use GraphQL or Sparkle. Great. But we don't query our software very often. We've got all this data we collect, but we've got a huge amount of structured data which is critically affects everything which happens to the rest of the data. And it's just sitting there, and we don't really do much with it. We don't query it, we don't ask what the structure is, we don't follow what's going on over time very often. So why don't we query the software itself to learn trends, problems, and opportunities? So I've kind of said we don't do this, but But really people do this because we write unit tests. So given an input A, I expect the output is B. And really this is, you think of this as a sort of simple query about the software. We're given one input and we expect the output is B. And then we write lots of these. And then we get tired of writing these, so we do randomized testing and we give some random inputs that satisfy some property P, and we check the output satisfies Q. So this is sort of more queries we can do on the software. And this gives us insight into the program, helps with maintenance and so on. So if we've got tests, then we can sort of refactor more confidently. New people can sort of read the tests and hopefully work out a bit more about what's going on. But we can go a lot further. So why don't we load the source code into a database, run queries to find bad code? So I'm not going to claim that this is in any way a good schema for storing source code, but let's say we've got a table called statements, and that has a field called type, which is looking for try-catch blocks, let's say this is Java or something. And we're going to look for all the try-catch blocks where the second child has 0 statements in it. So this is cases where we've just had an empty try-catch block and we're just sort of silently dropping the error. And in general, this is a bad sort of thing to do, I would say. You might say this is bad style. And indeed, there are tools that already do this. But we can have other ideas. So we can put our program in a relational database. We can write other queries using SQL or something to find out things. So we don't have to find out, is method A always called before method B? So this might be something where we always have to do some setup thing before we do something else. Or of course, the method C always wrapped in an exception handler. We can do statistics on the usage of libraries, things like that. And I think this is a compelling idea. We search the data for anomalies. We search data for insights. We search data for opportunities. So why don't we search code? Why don't we search code for things? And I should say, I haven't put on the slide, but there is a commercial tool which lets you do this. There's SEML code from Oxford, or SEML from Oxford, so a tool called SEML code, which allows you to query the structure of your program. But we're still doing logic, because really what's going on, the queries are specifications written in logic. So if I rewrite that SQL, or obfuscate it, into what I was saying was there exists a line, the question is, does there exist a line number with the second child where the statement is a try-catch block of that line number, it's got some parent and some other child we care about, and the number of statements that have that thing as its parent is equal to 0. So this hash means but really we're still doing logic, but we can sort of phrase it as SQL queries or something. And the point is, rather than this big upfront specification where we sit down and think really hard about what does it mean to be Twitter? How can I write down one big giant phi that tells me I should be really good at maybe getting messages to some people sometimes? And I haven't write that down. But we can write lightweight specifications to do things. We can say things like, we shouldn't have any empty catch blocks. We shouldn't have cases where we haven't called the initialization method before letting an object leak out of the method. And we get the computer to do the boring stuff. Like, some of these things are sort of captured by code reviews or testing. We get the computer to do the boring stuff. We can just set up a load of queries. If any of them bring back anomalous results, then we can use that to have a look at the system. But now we can go further. So this is where I think it gets much more interesting. There's this sort of field of deductive databases, where so I think SQL, what it's doing is you're giving it a bunch of facts and it's deducing new facts from the data you've given it. And you can get a bit more expressive than SQL by going to Datalog. So if you've ever done Prolog or something like that, Datalog is a bit like Prolog, except programs always terminate, and you're not allowed to have infinite data. But don't worry about that. So the idea is, we have a program, and let's say in the program the only things we care about are statements where we make new objects and statements where we do assignments. And what we're interested in is, can certain variables eventually end up pointing to certain objects? So we take statements like this is meant to be the line number here, and we convert that into a fact for the database. So you can think of this as there's a table called new, which has got two fields, one of which is the variable, and the other one is the name of the object, which is created that line. And there's another table called assign, which has two fields, which is two variables, and that represents that at some point in the program, X was assigned the value of Y. And then, because it's a deductive database, we can actually deduce new facts from the database. So we can say, what we want to work out, is it possible for variable x to point to object O? So that's true if we created an object O and newly and put it into variable x. It's also true if there's a variable y which pointed to an object O and we assigned y to x. So this is true. So now there are sort of data log engines like one called BDD, but you can buy commercial ones like Logic Blocks. You can, the Microsoft's Z3 tool has a data log mode. And now we can answer queries like, can this variable ever point to this object? Which sounds kind of dull, but we can also ask things like, can this sensitive data ever flow to this public output? So what it's doing is, can you imagine, it's like a little one of these radioactive pills you take, sorry? Isotope, thank you, yeah. And then you watch it trace through your body and you can see how your insides work. And we can do that kind of thing with this. We can watch how objects flow through the system. Obviously, this is very simple. If programs are written using only these two statements, then my job would be a lot easier. But with more complex rules, we can ask things like, will this object's field ever point to that object? Can this object ever be reached for two threads, which is important if you're worrying about race conditions or deadlocks? Will this virtual call site ever call method body D? Can we just delete this to method body D? Now we're going further. So that was the kind of thing where we can deduce things from the facts, but now we can, are there other tools for reasoning about the extension of the program through time, if you like. So the problem with that system was that, the previous system I showed, was it kind of assumed that everything in the program all happened at once. But we can use things like temporal logic. So this is this kind of modal logic where we can make statements about how things happen across time. So you think roughly logic is like ands and ors and implies, and add at least two new things. One is if you write G, then something that means that G holds for all times in the future. And if you write F, then something that thing will hold at some point in the future. And now we can start to make statements that say things like, at some point in the future, it will be the case that we can always reset the system to back to a normal state. And then there's tools which can actually check these temporal logic statements against models of programs. So things like Spin, USMV, Pepper, which is developed in informatic building here, TLC, which is temporal logic checker for temporal logic fractions. And essentially, they make again, it's the same idea. We're making queries on our software thought of as a database, and this time the query is, are there any paths which don't satisfy the formula? So here's some examples. So we can say, if we have some invariant that we want to hold for the entire system, so never explodes, then we can say, we can make a statement, so this holds for all time, G invariant, but then we can start to make more complex ones. It's never the case that we're both reading and writing at the same time. It is always the case that whenever there's a request, then at some point in the future, past when the request happens, then that request is granted. So we can sort of make statements which are conditional on something else happening. So we can completely model something like the user being completely non-deterministic, a complete cloud of confusion. Sorry. But we can always say the system will do the right thing. If there's a request, then it will be granted. We can say in all future times, so that's the G, there will be at some point after that, then we will be enabled. So it's not saying that at all points in the future we'll be enabled. We're saying that at all points in the future it's possible to get into a state in the future after that is enabled. So you can see that you can write quite sort of expressive specifications like this and get them automatically checked by a machine. Finally, we can talk about these sort of satisfiability solvers. So satisfiability is this problem where you're given a Boolean formula and you can ask the computer whether is there a satisfying assignment for this. And so some of you may know this is sort of the classic NP-complete problem, and people will sort of sternly look at you and tell you that's intractable. But there was a big breakthrough about 10 years ago, about 10 years, within the last 20 years, where now these tools are actually really really practical. So you can, they're now used for all sorts of things. So SAT solvers are used by package managers to work out a sort of coherent set of packages to install on your Debian system. They're used by the Eclipse plugin manager to work out how to install plugins in Eclipse. They're used by Brian to, to generate test cases. They're used by a sort of a wide range of things. And some work I did with the company Symphonic, who work over there in that big ugly building. So they sell a tool that's sort of basically an authorization server. It has a bunch of authorization rules which are set by the user, and they're interested in whether or not you add a new rule, is that a waste of time? Is it sort of obsoleted by the rest of the rules? And so one of these SMT solvers, SMT is an extension of SAT where you can add in extra theories. So it means satisfiability modular theory. So you can add in facts about arithmetic or interpretive functions and the like. So you can define in one of these things, you can define a function in a kind of Lisp-like language, a bit like C. Policy 1 takes an input and gives you an outcome, so this might be commit or deny. Policy 2 takes an input and gives you commit or deny. You can say to the approver, I think there is an input where these two things are equal. And check satisfiability, so that sort of goes away and it tries to come up with an input where they're equal, and it's a get model, and it'll tell you an input where they're equal. So you can see somewhere where these two policies overlap and give you the same answer. So you can sort of then go on to ask more interesting questions like, is there any policy where any input where they give different answers? Is it the case that policy 1 is always shadowed by policy 2? Things like that. So that's really brief. So all I want to get across is the idea that these things are not as heavyweight as they may sound. It's possible to do very lightweight things. These tools are often free. So Z3, which is the one we used to do this, used to be £10,000. No, dollars. Slightly better, isn't it? Dollars. To license it from Microsoft, who made it, but now it's free. I believe MIT license. Anyway, conclusions. So I'm going to claim that formal methods isn't a heavyweight, sort of difficult thing where you spend a day and a half proving that reverse of reverse is the same thing as not doing anything at all. It's basically not much more than querying your software for interesting things, just as we would query your data. So why don't we query software to find out what's going on? And there's lots and lots and lots of logical tools from academia, but there's so many underexplored opportunities, and this is what I want to sort of find people to work with. So there's not much work on actually checking user interfaces for stuck states. So you can sort of think of the pages in some websites as a great big graph. You can get between them using links. Is it possible to get to a part of the graph where you can't actually get back to where you're meant to be? Things like that. Or are there confusing parts? I mean, can we model the state of mind of the user using different parts of the website in a kind of formal way? Can we check legal compliance of software? So some people would, according to a conversation I had last night, no, because it is impossible to find a reasonable person. However, we do this already. I mean, there's probably people in this room who are encoding legal rules in their software. Is it happening correctly? Are the rules correctly applied? There's now people who are basically being prosecuted because a piece of software said yes or no. And I mean, maybe they can argue against it in court, but they still have to go to court and spend a lot of money. How do we check that it is actually doing what the law says it does? One big thing is checking your configurations of expensive things like cloud services. So if you're using AWS or Azure or something like that, are you spending more than you could be? Have you set up the rules wrong? Something like that. This, I think, is I mean, Microsoft has done some work already on using model checkers to check Azure. I said that AWS, they've used model checkers to check the correctness of some of their algorithms they used around AWS. But there's not much for the users. What about the users? How do you check that you're using the web services correctly? If you're running an online game, is it solvable? Is it fair? Is it fun? Can you formalize these things and have them checked as you're doing updates to it? Can you just have computers basically playing it in the background, trying to work out, is it a fun game, is it solvable? I should say, there's some really fascinating work by, there's a PhD, or she just finished a PhD from CMU, or Carnegie Mellon University in Pittsburgh, about encoding games as a kind of proof search. So interactive games using proof search, and there's a whole world of basically using formal methods to model interaction in games. It's really quite fascinating. can we model the user states of mind? I mean, can we, the sort of traditional problem with using formal methods by that sort of objection that comes up is that you can never model humans. Can we? We can try, come on. So I want to apply logic to real world problems. Can you help me? That's my email address and that's me on Twitter. Thank you. Does anyone tell me I'm wrong?
Question?
So you talked about the satisfiability query. So is it possible, as you also mentioned the NP problem, so is it possible you run a query and it just goes on for?
Oh yeah. So definitely, yes. So a lot of these things are heuristic based, and it's well known that there are these sort of so-called pigeonhole problems which always guaranteed to hit the worst case of these solvers. It turns out that often in practice that often in practice it's possible to hit good cases with these things. And one may speculate that humans are actually very boring, and we only generate problems which are easily solved. So yes, I think yes. So no one's solved P equals NP yet, but there are really good heuristic algorithms which work in a lot of cases.
Are there any ways to get them unstuck? So if they do run forever, then ways that...
Yeah. So I didn't talk about, so one thing is you can often supply hints to the system. So sometimes you apply extra constraints, and that will help it. The other thing to do, which I didn't really talk about because it didn't really fit my narrative, was interactive theorem proving, where you make a statement to the computer and it doesn't try and prove it itself. It doesn't try and run the query itself. It's you have to actually help it do the proof, and that's a lot more expensive and a lot harder.
What sort of help are you looking for?
People who have problems. So, I mean, it's all very well me sitting in a big tower in Glasgow trying to think of real-world problems, but I really love I mean, this work I did on authorization rules was interesting because I know actually people are going to use it. So I'm looking for people who've got, if you're writing kind of rule-based software that would be amenable to checking would be an obvious thing. But also, I mean, I'm quite interested in this idea of using modeling user interfaces to find out whether or not are there formal ways of applying design constraints, things like that.
If a team was to start doing this in their own project, what would be the best place to start?
I would say, I didn't really talk about this, static analysis tools which come preloaded with rules to use. So there's one produced by Edinburgh University called ThreadSafe. Well, not by Edinburgh, I spin out Edinburgh University called ThreadSafe that I worked on. There's also some systems like PMD which allow you to write your own rules to do things. I would say it's worth having a go with something like TLA+. So the problem there is you have to write it in its own language, but you can sort of use it as a design language. There's another nice tool called Alloy from MIT, where again you have to write it in its own language, but they have this nice thing of doing micro models of software. So the idea is to use it as a design language that you can then check. But I would say using static analysis tools is one place to start.
So I'm interested in already using static analysis tools, but I was quite interested that you mentioned about taking, not static analysing code, but taking it and putting it into like a statements table in a database with some meta information around it. Is there a formal name for doing that process, taking code and actually put it into some kind of relational structure?
No.
Is there some tools you could recommend to actually do that I could look into?
So as I said, there's this commercial tool from this Oxford company, Semel, which I don't actually know much about, which does that. I don't know of any kind of easily accessible tools that do that. I think there ought to be. Not that I know of. No. No. I think it would be a tremendous thing to do. I should do that. Sorry. Goodbye.
Maybe it's a bit of a follow-on from that question, but it seems to be a lot of the problem is going from arbitrary language to AST or other representation of code that you can then do this analysis on rather than requiring people to do TLA first.
Yes, yeah.
is that an area of research, or is that?
Yes. So I mean, so actually maybe there is a formal name, which is model extraction, which is the sort of formal languages a lot of these tools use is not Java or C# or something, but you translate from Java into their formal model, maybe not in one step. So often, sometimes it'll happen on the fly because that's more efficient, because you may not explore the whole program. And that is an active area of research, is working out how best to do that, because inevitably when you're translating, these languages are very complex and you have to approximate in some way. And so there's these things that's called a CGAR loop, which is counterexample guided abstraction refinement, whereas you try a rough one, if that doesn't work, you try a slightly better one, and you go around in this loop trying better and better abstractions of the code. Yeah.
Are you restricting yourself purely to studying like static code, or are you interested in sort of systems and configurations as well? So I can imagine there are interesting things to prove, such as any resource could never be accessed by another resource, or guaranteeing that a resource will always be available out of all the resources, given all possible failure methods and things like that. Is that?
Yes, that's definitely the kind of thing I'm interested in looking at. I mean, so to answer the point on static things. So yeah, most of the things I talked about here were sort of looking at the static structure of the code and trying to infer things from that. But I think there's an interesting opportunity in looking at dynamic log data and how that, because if you know something about how it might happen at runtime, then you can use that to refine the static analysis. But it is possible sometimes to get approximations of what's going to happen at runtime where you can actually have things like resource correctness, as long as you know enough parameters of the actual environment it's going to run in. But something like Rust already allows you to sort of guarantee data race freedom, so actually making sure that concurrent processes don't conflict and writes to memory. So it is possible to do things statically. Does that answer your question? Yeah, you can.
What are the holes in the research? Because you're talking about accessing resources, so presumably if this was an easy problem, they would run a tool and they would say, you have a deadlock here. Why can't I do that here?
So the problem is that in rough terms, there's far too much diversity in how people write programs, and and the problem is that often, well, that's one of the problems. I mean, in general, it's an undecidable problem. And the other problem is that you write a tool and it's necessarily heuristic based, because it's going to pick and choose some abstractions. And often, when you're trying to analyze some code, then you've got aspects like a certain framework they've used, the coding style of the authors, the sort of when they learn Java. And so, which, I mean, roughly like counting the rings on a tree is how deep your inheritance hierarchy is. So a number of years ago you learned Java. You should read some of the code in the JDK. That's the old MIDI synthesizer stuff. That's amazing. Yeah. So I mean, what I mean is that there's a sort of huge diversity of programming styles and programming languages, and it's difficult to make one tool which works everything. So I think that this idea of the programmers themselves writing queries to try and make that accessible to programmers so they can tune it to their own needs, because they, so as I said, I worked on this static analysis tool called ThreadSafe, which is meant to find Java concurrency bugs. And one of the problems we had there was some people would use it and go, oh, it found loads of bugs, that's really great. And some people would use it and it found nothing because it just didn't, our assumptions didn't match their coding style. Other sort of holes in the research are just general scalability. We don't know how to solve a whole bunch of problems that sort of come up in practice, and there's a kind of thing where it's sort of, there's a new problem and we have to come up with new ways of solving it, and it's difficult to it's quite easy to say, oh, let's just find deadlocks, but deadlocks happen in a huge number of different ways. So, I mean, for instance, you can just deadlock by having locks in one Java program, but you can deadlock through the database or something, and that makes the problem much harder. So the problem is there's just a huge number of ways things can go wrong, and you have to code up ways of finding these things. So that's why I think writing sort of things as queries and trying to make that accessible to programmers is one way of getting around it.
One last question. Thank you very much.
Good.
Right, thank you very much, everyone. I guess this ends our event tonight. If you could please give us a hand kind of putting cans and stuff in bags, that would be great. Well, again, I'd like to thank our sponsors, Skyscanner, Cultivating Informatics Ventures, and I guess after we finish setting up, we're all heading to the pub at the Pear Tree, so if you fancy talking more about the topics that were presented tonight, yeah, just join us at the pub. Yeah, thank you.